Hi there. How are you? Hello. Hi
Hi,
there. How are you?
I'm good, sir.
Your school started?
Starting from a day after, I'm going tomorrow. So,
You going tomorrow?
yeah.
Okay. Perfect.
Also, by the way, in boards, I got in physics 3.
What did you get?
I got a 3, same as box.
Same as mocks.
Yeah, 3. But I don't know the marks.
Oh, they don't give you the marks or what?
No, in the certificate, they didn't give the marks, only the achievement level, nor the paper.
Oh no. Okay.
Yeah, maths and physics were hard this time.
They're actually hard. Like how was the overall like your school boundary or something? Or average grade in
Grade
school?
boundary?
No school grade?
School grade, like how much like people got in physics?
Mm-hmm. Mm-hmm.
Some like mostly I think people got like 4 or 5 or 4. But it was like considered for everyone. Most of them like as a secondary subject because they count 8 subjects, right? So some people took 3 sciences, 2 sciences. So out of that, everybody's physics was as counted as secondary.
Okay, and for you?
Same for me. Uh,
Okay. Okay. So how's your overall score? I mean, like, in grade
uh,
10,
I out of 56, I got 35.
45. Okay. And which was the highest graded subject?
I got good in design.
Design technology.
Yeah, like e-portfolio.
That's cool. That's cool. And which
But
is your
like in school and all, which we practiced, physics was like completely harder in the
well, yeah,
board.
I know. Like there's this MYP, they give randomly. I mean, randomly anything, and they don't even like tell you that priorly or there's no question paper also available.
Yeah, yeah. And for DP, I'll have like prior, right?
Yeah, yeah. We have like the mock papers as well and everything.
Okay, okay.
So what's your HL subject you said?
Yeah, so HL is my math AIHL.
Hmm.
Then computer science I took and business management. And then SL I took Hindi, English, and physics.
That's cool. Hindi, English, and physics, no? Okay.
Yeah.
So
They were anyhow recommending everyone to take either one science
yeah, yeah.
for either SL or HL.
True that. Because and then com science goes really well with physics. I mean, physics and maths.
Okay, yeah, yeah.
So we'll begin with the the topics only. All right.
Okay, yeah. So, like, I don't have the syllabus yet, but like, you can tell which topic to start with.
Yeah, yeah. I'll tell you. I'll tell you. I'll show you the syllabus. I mean, okay. So we are beginning with the theme A. Okay.
The
Theme A, and that is
theme.
called as um, the kinematics or the motion.
Okay.
Right.
So, will I have my like any concepts of 10th or ninth grade,
Yeah,
even
yeah.
11?
Everything will be there, bro.
Okay.
So motion and then space and time.
Okay.
So in this, let me just show you the what all topics are there if you don't remember. You see, these are the topics.
Okay. Kinematics, force, momentum. Okay. All this. So,
A1, A2, A3.
most
Yeah.
of them are last year's in theme
Yeah,
A.
yeah. Yes. Same theme A. Okay. So let's begin this theme A1. I mean,
Okay.
so in A1, that's basically the kinematics. And if we are able to recall in kinematics, basically we describe this motion of an object.
Okay.
Describe the motion of an object.
Okay.
Now, in order to describe motion, we use certain terms like distance, displacement, speed,
Okay.
velocity, acceleration, and even like certain terms like
Okay.
instantaneous velocity, and all. Okay. So
Okay.
before we directly jump to it, let's recall what are the difference between scalar and vector, and then what are the scalar quantity and what are the vector quantity.
So, scalar was distance.
True. So in general, the scalar is defined as the quantity which describe well with only with its magnitude.
Okay, only with the direction.
Only with magnitude.
Magnet.
Magnitude is like number.
Okay.
So the quantity which describes best with magnitudes are called as the scalar. For example, um, this mass is a scalar quantity.
Mm-hmm.
Distance is also a scalar quantity. Time is also a scalar quantity because time doesn't varies with the direction.
Mm.
Similarly, like um, the pressure is also a scalar quantity. Work, energy, and then power will be also a scalar. We will see that like over the course of.
Okay.
Vectors quantities are the one which describes really well with both its magnitude and then plus direction.
Okay.
So you need both magnitude as well and as well as a direction to describe it well. So examples over
Okay.
here will be the displacement, velocity, acceleration, and force. Okay.
So in scalar, you wrote work, energy, power. Or what?
Yeah. Work, energy, power, WEP.
Okay.
Because work, energy, and power are the scalar quantities. See now, think about it. Power of a machine will not change if you change the direction of the machine, right?
Mm. Yeah.
So this quantity do not change with the direction. I'll also say that do not change with direction.
Okay.
But this quantity get altered, it changes with the direction. Its meaning gets changed with the direction.
Mm. Okay.
Okay.
Yeah.
Cool. So that's a quick recap of like what we have done, scalar and vector. So the vectors are always magnitude and direction, and we have represented vector with the arrows, right? Remember
Yeah.
that? Where the length of the arrow represent the magnitude, and then arrowhead tells you about the direction.
Okay.
Okay, so in order to describe this motion of an object, we use the certain terms like distance and displacement, and we
Okay.
also say the motion is relative. I mean, okay, so what do you mean by that? The motion is relative.
Okay.
Here, the motion is relative means the motion is always defined with respect to an observer. So let's look at this example. If you are sitting in a train and in a train, and let's say the train is moving with the speed of 60 kilometer per hour to the right. So here's the observer A and then there's another observer B. You both are in the train, and then if a platform, if the observer C is watching you, then what will be the observation from the C gonna be? C will see that like A and then B, they both are moving in the
Mm.
forward direction with the speed of 60 kilometer per hour. Okay.
Yeah. Mm.
On the other hand, B will see that the A is not moving at all with respect to him because they both are in the same train.
Yeah.
And B will also see that B himself is at rest and C is moving backward with the speed of 60 kilometer per hour. So for B, the platform is moving backward with the speed of 60 kilometer per hour. Do you agree this observation?
Yeah. But isn't A also moving respective to B? Like it's following B only.
Yeah, it's following B only because these two are in the same, the train. So they both will see the same, the scenarios. I mean, for the C.
Okay.
Makes sense, right?
Yeah.
So A and then B will consider themselves at rest with respect to one another. So they're not moving at all.
Okay.
Okay? So we'll see that the motion is always relative. What do you see? It's not necessary that the other person or other guy will see the same motion. So motion is always defined with respect to the observer. Okay.
Okay.
So coming to this points to revise distance and displacement. So distance and displacement. So if you start your journey, let's say from this start point, and you end up reaching here, that's your end point, and then observer reaches over here. Let's say you move throughout the path of 500 meter. So this 500 meter is known as its distance covered, the actual
Okay.
path covered. On the other hand, if I draw the start point and then draw a line which goes directly from start point to the end point like this,
Okay.
this path is basically called as the displacement. So the displacement is the shortest or straight line from start point to the end point. So I'm going to say
Okay.
straight line from start point to end point. And since that's the reason that it has it is a vector quantity because it's a displacement. So
Okay.
in a particular direction or always a straight line. So it's a vector. While
Okay.
distance was simply a scalar quantity because the actual path covered. So this was what the actual path covered. Actual
Okay.
path. Cool, right?
Yeah.
If this observer starts from here and it eventually travel like all these and eventually reaches to the same point,
Okay.
end point, then
Mm.
start if the start and end point is exactly the same spot, then I say the distance covered will be whatever the path he followed, but the displacement has to be zero.
Okay.
Do you agree why the displacement gonna be zero in this case?
Yeah. So like there's there's a path distance to follow and the start and end point is same, right?
Correct.
Mm.
So because start position and end position is the same.
Okay.
Start position and end position is same. That's the reason its displacement gonna be zero.
Okay.
Now in this example, you will tell me how do I calculate the distance covered and displacement. So let me just write on that. It's a checkpoint. Let's say here is this guy who's walking on this track from point A, B, C, and then he returned back to the point D. Let's say A to this is 0 meter, it's like 20 meter, 60 meter. That's a marking has been given. This is a 40 meter.
Okay.
So he followed this trajectory. He moved from A, B, C, and then returned to the D.
Okay.
Okay.
Yeah.
So what will be its total distance covered and displacement? Distance and displacement.
So that's CP you wrote?
C and then D. That's a checkpoint. That's nothing. That's a question.
C.
Checkpoint.
Okay. Okay. Point. So from there to it's going.
That's your start position, right?
Yeah. Hmm.
And it followed like this trajectory and returned back to this.
Okay. So I need to tell the distance and displacement.
Yeah.
So distance will be like 120, right?
Distance will be 120.
Like first he is going to 20. Oh no, 1 second. And firstly the displacement will be 40 itself.
40. And then what is
Distance,
which direction?
what displacement?
Yup.
Like he's going back from there to there.
Going back. So can I
Yeah.
say the left or right or something?
Left.
Correct. You could also say that like north, south, east, west, like that way.
Okay.
Yeah. So anything works, but you need to define this direction as well, while writing displacement.
Okay. And for distance, like he's going right. So 100, right? For distance.
Distance will be, how come it
Like
will be 100? Yep. Go ahead.
60, 60.
60,
160, 160.
60, and then 40, right? So it'll be
Yeah.
60 meter plus 60 meter plus
Plus
40 meter.
40.
That's
160.
160 meter. Understood?
Yeah.
So you need to consider both way.
Okay.
Cool. How about like this? If this guy is tossing the ball from the cliff of a height of, let's say, 40-meter again, and then the ball follows like this trajectory and returns back over here at this point. That's end point.
Hmm.
And let's say the ball move upward with a 25-meter up from this.
Okay.
Then what will be the total distance and displacement?
And how much is down? 40. Okay.
40 meter is the height of the cliff.
Yeah. So what's the distance, right?
Yeah,
So that will be 65.
that'll be 65.
Yeah.
Distance or displacement?
Distance.
And why again?
Well, what?
So
Yeah.
25 it goes up,
Yeah. And then 40 down.
25 it comes back to the same
Okay.
spot.
Okay. Yeah. Yeah. Hmm. So it'll be 65 plus 25, which is 90.
So 25 plus 25 plus 40 gonna be a distance.
Yeah.
Okay. And displacement will be simply 40 meter.
Yeah.
What will be
Displacement
displacement?
will be 40. Displacement, but for displacement, I mean like he'll bounce the ball, so won't we consider up?
Okay, I'm not considering that part. Like, let's say it hits the ground, that's it. And it
Okay.
stops there, I mean.
Uh,
Okay.
40. Yeah.
So that's your start point, that's your end point. So that'll be 40 meter.
Yeah.
Again, direction.
Hmm.
Which direction?
So direction. Okay. It's going south.
Yeah, you can say the direction, it could be south, okay, slash down,
Okay.
right?
Hmm.
Or can I also say, in graph, I mean,
Hmm.
when something is going up, that'll be positive, down will be negative.
Negative.
Similarly, the right would be positive and left would be negative, right?
Hmm. Yeah.
That's the general Cartesian symbol. So I can say, since it is going down or south, I could also write a negative. So you could write any of them,
Okay.
negative, south, or down. Cool.
Yeah. Fine.
So that's how you can calculate the idea of distance and displacement. So you'll remember now the displacement is a vector quantity, distance is a scalar quantity. Okay. Or
Hmm.
another example, let's look at this as well. Let's say this observer starts its journey. He moves 4 kilometer to the east, and then he moved 3 kilometer in the north. Okay, 4 kilometer in the east, 3 kilometer in the north.
Yeah.
What will be its distance and displacement?
Start and end is the red part, right?
Yeah,
Okay. So distance will be 4 plus 3, 7.
true.
And displacement will be just 4.
Why?
Like he can go that you can make the path northeast.
So this, right?
Yeah.
But this won't be 4, no? You know math, right?
So we'll just say displacement as north. No, I don't know. Northwest or something direction.
North, northwest
Northeast.
or
Northeast.
northeast is
Northeast.
sky. But that's a direction, bro. How do you calculate magnitude?
Uh, so will we do the Pythagoras theorem or something?
Ah, yes.
Okay.
Did you understand? So first you're
Yeah.
gonna draw that
I
what the
understand.
displacement would look like. No.
Yeah.
With, and in order to draw displacement, you just think about start point and end point and draw a straight line.
Hmm. Okay, I'll tell the this Pythagoras theorem.
So
So
this will
3
be
square
3 square
plus
plus 4 square
4 square.
and under root. That'll be the displacement.
Yes.
And that'll be 5, I think.
So
5 kilometer.
yeah, 5. 25 the root will be 5.
Correct. So the 5 kilometer northeast will be the displacement. And then distance would be straight away 4 kilometer plus 3 kilometer, 7 kilometer.
Yeah.
Are you fine with this? All these examples?
Yeah, I'm fine.
Cool. Then the next term which we need to understand is basically the speed and velocity. Speed and velocity. So again, like speed depends upon how much distance has been covered every second. So speed is basically the distance covered per unit time. Distance upon time.
Okay.
Velocity is the vector version of it. So velocity is displacement upon time.
Time. Oh,
They both will be measured in the unit which we call it as meters slash second, okay,
okay.
or
Hmm.
meters per second.
So yeah, I had a question about relating to this itself. I
Hmm.
wanted to ask. So 1 second. No, no, down only some last like long back we did.
Go ahead, no? Yeah.
Yeah, just yeah. So one was that unit thing. Like, how do you make it -1? Like,
Acha, acha, yeah.
yeah,
So
that was
in
one.
units, you're gonna always write in the index form. So if I write meters upon second, whatever the quantity is in second, you write it like this way: ms minus 1. Why? Because this power is 1, right?
Okay,
If it is meters per second square, you would have written ms minus 2.
okay. And what about both ways? Like even on the
If the both
numerator.
are in, if let's say this is a unit, for example, I would
Hmm.
write meter inverse, second inverse. Anything, if you're bringing it up, just put a negative sign. That's it.
Okay.
Okay.
Yeah. And then one I had for certainty, uncertainty, that random error and all.
Okay. That we will. I'll take you in the next class.
Yeah.
The that. Okay. And let's see your what your school starting with. Then we
Hmm.
will go accordingly. So I said the speed and velocity is both are measured in meters per second, and displacement upon time will be the velocity, while distance covered upon time is the speed.
Yeah.
Now speed is again a scalar quantity, and therefore no direction is needed.
Okay.
is needed. Velocity is what? The vector quantity. Therefore, you need to specify direction.
So
Specify direction.
specify the direction.
Yeah. So what is that again? Like, over here, if the car, let's say it is moving forward, and if it is not changing the direction, then I can say, okay, so like for example, let's say the car is moving 40 meters per second in a straight line like this.
Okay.
And if the car is moving 40 meters per second in a straight line, now in both the case, it's moving in a straight line, so that I can say the speed and velocity will be equal. Why? Because the direction is not being changed.
Okay.
Makes sense, right?
Yeah.
So you can say velocity is always speed plus direction. Speed plus direction. If the direction is not changing, then I can say velocity is equal to the speed. If the direction is changing, then I can't say the velocity is equal to the speed.
Okay.
Got it?
Yeah.
Make sense?
Yeah.
So that's the reason your car, like shows you, like there's something called a speedometer in your car, right? There's a speedometer in your car.
Yeah.
Because your speedometer doesn't show you the direction. It only shows you, like how fast the car is moving. It only shows you, let's say, if it is moving 60 kilometer per hour or 40 kilometer per hour, but it doesn't talk about in which direction it is moving. Correct?
Yeah.
So that's a scalar quantity and vector quantity. Is it very clear?
Yeah.
Okay, I'll make a note as well, like this, that vector quantities can be negative,
Okay.
but scalar cannot be negative.
Yeah.
Can't be negative. So speed cannot be negative
Because the direction is not
because of
specific.
the direction. Yeah. Okay. So that's a note which you're gonna remember all the time.
Okay.
So whenever we are dealing with a vector quantity, we also has to like deal with the direction. Okay. So like
Okay.
okay. Moving ahead, then there is something called as uniform speed or uniform velocity. Uniform speed or slash velocity. Then if a car covers equal distance in equal interval of a time. So if a car is moving, let's say 5 kilometer per hour, and if I make a time span of 1 hour, let's say if these blue dots are 1 hour apart, roughly, okay, then in every hour the car is covering 5 kilometer of its distance.
Yeah.
Okay,
Yeah.
5 kilometer in 1 hour. So that's the meaning of uniform speed or velocity.
Okay.
That means it's covering equal distance slash displacement in equal interval of a time. Got it?
Yeah.
So equal distance in equal interval of a time. That will be giving you the idea about the uniform speed.
Okay.
Understood? Then there is
Yeah.
an acceleration. Then what is the meaning of acceleration?
So like the change in velocity over time.
Change in velocity over time, right? So
Yeah.
acceleration is if this velocity is growing or if the velocity is increasing, then how, like acceleration is changing, correct? So for example, let's say if the car starts from the velocity of, let's say, 0 meters per second, and in first second its velocity increases to, let's say, 5 meters per second, then it moves to 10 meters per second, then it moves to 15 meters per second, then its velocity increases to 20 meters per second. Let's say this way. So
Okay.
can I say its velocity is growing every second by this 5 meters per second, right? Isn't it?
Yeah.
By every second it increases, isn't it? 5 meters per second. Understood? So that's how we're going to say acceleration is. So when the object speed is increasing, then we'll say it's accelerating. Clear there?
Yeah.
Now in this case, the speed is increasing every second by 5 meters per second. And it's constant. So this is what it is called as uniform or constant acceleration. So like uniform, let me just also tell you this. So for example, acceleration of 5 meters per second square, it means its velocity increases by 5 meters per second in every second. As the each second passes by, its velocity would be more and more by 5. Okay.
Yeah.
Now you saw the above example. Let me tell you this example now. Let's say the car again. It starts from 0 meters per second. In first second, its velocity increases to 3 meters per second. Then in second, its velocity increases to 7 meters per second. And then 15 meters per second. Now, is this example of uniform acceleration?
4 meters, 0 meter. No. Oh, no.
No, right? So
No.
its velocity is still increasing, but it's not increasing constantly, right? With the
Yeah.
same amount. This is called as non-uniform acceleration.
Okay.
Non-uniform acceleration. But above one, this is called as uniform acceleration.
Okay.
So the word uniform acceleration is when the speed increases every second by a fixed amount. So hence we calculate the acceleration as its change in velocity upon time taken for that change.
Okay.
Time taken for the change. Got it?
Yeah.
Sure, right?
Yeah.
Okay, so here comes this. And acceleration will be positive or negative as well, right? Your
Yes.
change in velocity will be always the final velocity minus initial velocity. Minus initial velocity upon this time taken.
Yeah.
And sure, the final velocity, I would write it with a letter like V. Initial velocity, I'll write it like U, and time taken to be the T. Therefore, this formula turns out to be A is equal to V minus U upon T.
Okay.
Okay. What is A? A is the acceleration, V is the final velocity, U is initial velocity, and then T is the time taken for the car to move from U to final to initial. Okay. Got it.
Yeah.
Okay. So sure. What is if we see this, like how does the distance covered is different when it is uniform speed and uniform acceleration. Uniform acceleration. So let's say again, if this car is traveling 5 meters per second at constant speed, constant speed, then first thing in the calculate uh, its speed after 5 seconds, or like let me just tell you speed after 6 seconds, and then second thing is total distance covered in 6 seconds. Okay.
Yeah.
And if I just replicate this over here, but I'm gonna change few things, huh? Look at this now. Instead of saying constant speed, if the car starts from initial speed of 5 meters per second and it
Hmm.
is also accelerating, uh, let's say 2 meters per second square.
So
All
that's
right.
every time.
Yeah, the 2 meters per second square is the same way. Every
Oh.
second, its velocity will increase by 2 meters per second, right?
Yeah.
Then how do the graph will change, right? Let's think about this answers. Yeah.
Yeah. So should I like describe how the graph will go?
Yeah, no, not describe it, but just tell me like how it. Write down the answers for this.
Okay, so for uniform speed, like speed after 6 second, firstly there'll be a straight line in the graph,
Okay,
uh,
fine. But
like
let's
that.
let's calculate speed after 6 seconds.
Okay, so like should I draw that in the graph?
You can do it. I just want you to. You can use any method, but try it.
Okay. So if it's like traveling at a constant speed of 5 meter per second, then
Mhm.
after 6 seconds it'll be like uh it's 5 meter per second, right?
Yeah,
So after 6 seconds it'll be at 30.
the speed will remain 30,
Yeah,
and then what will be the total distance?
total dis speed speed will be 30 and then the total distance covered will be so like after 30. So speed is this 30. So 30 into 6, right? 180.
Hmm. Bro, what does the constant speed means? You explain me this. What does the constant speed means?
Like it's traveling at 5 meter per second. Like it's traveling 5.
Does speed change in that?
Yeah. Yes.
Then how it's constant speed? If the speed changes,
No, like it's increasing by 5, right?
no, that's acceleration, na? Constant speed is what? Equal distance in equal interval of a time. That's what we said,
Okay. Yeah,
right?
so it'll travel at 5 meter per second every second.
So even after 6 seconds, the speed will still remain 5 meters per second, correct?
Okay.
isn't it?
Yeah.
Because the
So,
speed is, that's why it's called as uniform speed or constant speed.
okay.
Okay.
So now I have to do 5 into 6.
So now the distance covered. So the formula
30.
says that speed is distance into time,
Okay.
distance over time. I'm calculating distance. I know the speed is 5 meters per second. The time has been given as 6 seconds. Distance is what I'm looking for. And hence the distance is gonna be 5 into 6, which is 30 meters.
Okay, fine.
How would I calculate this then?
Okay. Speed after
Now
6.
this time it's uniform acceleration. Matlab,
Yeah.
if
So
speed
now
is, go ahead.
it's increasing by 2.
Yeah, every second.
So it's 5 at like at 1 second, right?
5 at the 0.
At the 0.
That's a start speed. That's the initial speed.
Okay. Then it'll be increasing by 2. 17 will be the speed.
17?
Yeah.
Correct. 17 meters per second. Okay.
17 meters per second.
Now, how would I calculate the total distance covered in 6 seconds?
Okay.
Because
So
this time the speed is changing. So you can't use this formula. Can you use this formula?
we might. Okay. No, you can't, right? It's
I
acceleration.
can't use this, right? Because the distance covered is not uniform, I mean. Okay?
Okay.
And therefore, I'm going to use this kinematics or SUVAT equation.
Okay.
Kinematics slash SUVAT equation. Right? Use
Yeah.
kinematics SUVAT equations in that. So how does SUVAT equations are different? So you'll see, like they're like these forms are there. Oh, bye. So the SUVAT equations are what? Like, you'll say the first V is U plus AT. That's the rearrangement of this form. If I could
Okay.
rearrange this to V is equal to U plus AT, correct? If you make V
Yeah.
as a subject.
And then you make T as a subject.
No, when you make V as a subject.
V as a subject. Yeah. Yeah.
Correct? Then
Yeah.
second formula is to find the total displacement. So I'm going to use S is equal to ut plus half at square. Can you recall you have done this in
Yes.
MYT?
Yes.
S is equal to ut plus half at square. And then third form is basically v square is u square plus 2as. That's the third equation. And then
Mm.
fourth one is average displacement. So the average displacement s, which is equal to the average velocity u plus v upon 2 times t. How many equations did you see? 4 of them.
Yeah.
And how many variables are there? 5 of them. SUVAT. SUVAT. Correct?
Yeah. So
Now,
that.
yeah, in order to use any of this equation, let me just write down what each term stands for.
Hmm.
And when you're going to use this formula only. So S will be like, the displacement.
Displacement. Yeah.
Okay, it's not the distance. So remember that basic difference.
Yeah.
U gonna be initial velocity. Initial velocity. V is what? The final velocity.
Okay.
And then A will be the uniform acceleration. Now again, this formula only works if it is uniform acceleration, okay?
Okay. Okay.
Not the variable acceleration. And T will be
Variable is
again,
same as uniform, right?
no.
Then
What is
what's
the uniform means that, like in this above example, if the uniform acceleration of 2, that means if it starts from 5 meters per second initially, in first second its speed will grow by 2, so it becomes 7 meters per second. In next it becomes 9 meters per second, and 11, and so on. This is called as
okay?
okay.
Okay. Yeah.
Non-uniform acceleration was this, no? See, the speed is not growing
No,
any
no, no.
extra
You
time.
said variable acceleration, right?
Yeah, that's called as variable acceleration in this.
Oh, non-uniform. So that
Non-uniform is variable, no?
okay. So that works in case of both. that acceleration.
So this formula only works if the A is uniform acceleration.
Uniform. Okay.
Okay, got it?
Yeah.
And then T will be the what? The time.
Okay.
If you see, out of this 5 variable,
So you
all
can
four
do the
of them,
last one. Last one.
yeah, last one is what? S is U plus V upon 2 into T.
Yeah. So at start it was initial at 5. 5 plus final was 17.
Okay. Upon 2 into time, you will get the displacement again.
Yeah.
Then you will be easily calculate this,
Yeah.
isn't it?
Into
Now,
time was 6. Okay.
6 seconds, no?
Yeah, 81.
81. So 81 gonna be a distance covered in this.
81.
Fair enough.
Yes.
So see, this is very important that the S will be the displacement, U will
Hmm.
be the initial speed. Okay.
Yeah.
A little like the extension of this third formula is also called as the timeless equation because I would not need any information about time. It's
Okay.
called as timeless equation. So when the time is not given, I'll be able to use this. Okay.
Yeah.
So
Sir,
what
I'll
is the
just use washroom and be back.
yeah yeah
Just a minute.
और भाई क्या बोलते हैं
Yeah, sir. You can see.
yeah there. So I was just trying to say out of this 5 variable whenever I'm using this there's things to know I mean so in order to use any of this equation there has to be the 3 variables known.
Yeah.
Okay, without
Okay.
3 variables you can't use any of them. So you make sure you get 3 variables. Even if
Okay.
there are like 2 variables which are unknown,
Yeah.
still can use any of this equation and solve it. Okay,
Yeah.
so you can see there are like 4 equations to choose from. 3 variables has to be the known in the question. Okay,
Okay. 3. If there are two like unknown, you were saying which equation for that the normal any three we can use.
any three, yeah, you can use. Okay,
Okay.
so for example, let's say S has been given, U has been given, V has been given,
Yeah.
and I'm looking for let's say A and then T. Okay,
Yeah.
so using this three,
Yeah.
can I use this to solve for A?
Yeah.
Correct. I'll be able to solve for the A, and once I got the A, I can use any other equations to solve for the T as well.
Okay.
Okay, so this
So,
equation must be used like
mm,
according to the data given.
so if I have three known, if I have three known, then I can use the fourth equation.
Then you can use any of these equations to solve
Okay. And
any
if
of
I
this.
have two known and two unknown, then
Then you can't. You can't use any of this equation.
so which one were you saying that two variable unknown?
Let me just give you this example.
One example, yeah.
Nothing. Okay, let me just take this example.
Okay.
So what this says that a train
So train accelerates.
accelerates uniformly, right?
Hmm.
From 10 meters per second to 30 meters per second. So can you
Okay.
identify? It's been given, U has been given as 10
Hmm.
meters per second.
V is being
T has
given.
been given, right?
Yeah.
Over the 1.5 seconds. So this T has been given, right?
Minutes. Yeah.
Find its acceleration. Does they ask you to find A?
Okay.
And the distance covered. So they're asking S.
Hmm.
Do you understand? So
Okay.
by reading this question, I just wrote down that what are the knowns are mean. So I write down like this way. Initial speed is 10 meters per second. Final is 30 meters per second. Now the time has been given as 1.5 minutes, right?
Hmm.
Could you see all these values are given in meters per second, meters per second. So I need
Yeah.
to convert this minutes into seconds. That'll be 1.5 into 60. No?
Yeah.
That'll be
Converted. Yeah.
90 seconds. Okay.
Hmm.
Now, what are the unknowns? So they're asking me to calculate A and then they're asking me to calculate S.
So
Okay.
we can get A first.
So you can get A first. Which equation you will get? Like, you'll use.
So first you'll use to get A, V equals U plus AT.
Correct. Okay. So you'll get the value of a T. Let's use that. Let's get the value of A first then.
Yeah. So A is my okay. So V is 30,
Correct.
and then U is 10, and then plus A we don't know, and then T we have given as 90 seconds.
Correct.
So then we take 10 to that side, 20 equals to A into 90, and then
Correct.
20 divided by 90.
Correct. So 2/9 gonna be basically the acceleration, right?
Yeah.
That was meter per second square. That's the acceleration you got, which is 2/9 meters per second square. Do you understand this? Now they're
Yeah.
asking me to
Understood.
calculate the displacement.
Yeah. So to get displacement, we can use any equation, right? Out of three.
Yeah. So now out of this, you have this equation in front. Let me tell you which equation you're gonna pick.
So we need to include acceleration now. So second one.
Second one works, right?
Yeah.
Because I know the acceleration. I know. Do I know the time? Yes. Yeah. So I'm gonna use second one to solve
Yeah.
for the time as well. Okay. Did you understand this?
Yes.
Okay. Then uh, you will do these questions. I'll send you this textbook as well. Okay?
Sir, the notes which you wrote today, can you share that? I wasn't able
Yeah.
to write everything. So.
Yeah. I will send you that as well.
Mhm. This one I have. Uh,
You have this textbook?
1 second. I'll tell you what all you shared me. You shared me the SOCOS Physics HL,
Hmm.
then tutorial HL. 1 second. No, sorry. Physics KA SOCOS 7th edition of Cambridge, and you
Ah.
shared me physics course companion.
Okay, cool. So you can go over that as well. Okay? So right
Fine,
now
sir.
you can uh, take a screenshot of this.
Okay.
Question number 5, 6.
Yeah.
Then you say 7, 8, 9, 10.
Okay.
Right.
Hmm. Just a second.
Sure. And I'll send you though like what we had just done the class. Okay, in the class.
Yeah. Okay.
And I'll send you the this textbook only. This is a new version of it. So you'll be able to access this. I mean, okay.
Okay.
Right.
Yeah.
Chal. So with this,
Okay.
I'll see you man
Tuesday, right?
Tuesday. Yeah. Cool.
Hmm. Okay, sir. Yeah.
Bye,
Bye.
bro. Bye.